Hi everyone, welcome to Calculus and Vectors, MCV4U. Today's lesson is on 1.2, slope of the tangent. Our learning goal today is to use limits to determine the slope and the equation of the tangent to a graph. So we're going to take a look at what limit is and finding the tangent of the slope. So first, I want you to understand the formula and characteristic of a line. So to find the slope of a line, m is equal to rise over run. So this triangle means delta, meaning change in. So to find a slope, you always need to pick 2 points that are on the line. So this is point 1, and this is point 2. And so this will be x1, y1, and this is x2, y2. So after you pick the 2 points, plug it in the slope formula, and you'll be able to find the steepness, which is the slope of a line. The slope y-intercept equation is y is equal to mx plus b. So one characteristic for parallel lines, we know that the slopes are going to be equal. If it's perpendicular lines, the slopes are negative reciprocal. So there's 2 ways to show it. Negative reciprocal, you flip it, or when you multiply the 2 slope, it equals -1. So let's take a look at the secant line. So secant line is a line that passes through 2 points on a curve. Okay. So the slope of a secant line, in this case, we're given point Q, which is x2, y2, and point 1, P, which is x1, y1. So these 2 points are on the curve, and we call that secant line. And to find the slope, it's exactly the same thing, rise over run. But one thing you notice that you see function notation. So function notation is, you can say y is equal to f at x. That's another way of saying y. So x is the input, which is the independent variable, what you're plugging in, into a function. So function in this case is the name of the function. It could be parabola, quadratic, cubic, linear. And then y is the output, okay, which is the dependent variable. So depending on the function, this is a formula that you will see, but they mean the same thing. And keep in mind, let's say we don't know the 2 points specifically, or one of the point. So you could say one point to be A, and the output to be f at A, because we're plugging in into a function. So it'd be f at A, which is the y value. Plug it in. And then Q, so you will notice that A plus H. The reason why it's A plus H is the difference. Okay. So what does that mean? So we want H to be smaller, the difference to be smaller if we're looking for tangent. But right now, H could be any number as long as you are consistent when you are plugging into y. So this is the formula. And how did I arrive at this? So f at A plus H minus f at A. Okay, so the second point minus the first point over A plus H minus A. Now you will notice that A and A cancels out. So therefore, that's why this is a simplified equation of a secant line, the slope of a secant. So consider f at x 2 over x plus 1. So it's a reciprocal function. Find the equation of the secant line that passes through 2 points. So what I'm going to do, I'm going to label, this is x1, y1, this is x2, y2. So we're given 2 points. So we can use m is equal to, so you don't have to use, you can, so it will be, for denominator, it's going to be y2 minus y1, x2 minus x1, which is -1 minus 2 over -3 minus 0, which is 1. Okay, so again, this is exactly the same as this one. Instead, this is using a function notation. Okay, so I didn't really need to use it because we are already given the 2 points that are on this curve. So I did not use the function notation. Then we are going to find the equation. So y2 minus y1 and x2 minus x1. So you can use this or the y-intercept form. So y minus 2 equals 1, x minus 0. Okay, so then y minus 2 equals 1x. So you bring it to the other side, x plus 2. So therefore, the equation of a secant line between points A, B is a straight line. A tangent line is, in simple term, it's a line that touches only one point on a curve. So secant, on the other hand, is 2 points, but you'll notice that it only touches at 1 point on the curve. So as the Q approaches the point P, so as you go this way, approaching, the secant line approaches a tangent line at P. Okay, so what does that mean? So we have a secant line that goes like this. Okay, and as I get closer to the P, it's shifting, right? Closer to touching P. Okay, it looks kind of messy. Okay. So the slope of a tangent line at this specific point could be represented like this. Now you will notice something unique is this symbol, limit, as h approaches 0. So we read it as h approaches 0. So what this means is that we're limiting value so that h is approaching 0. Why? Because we want the difference to be very, very minimal, right? So to be at point P, you want to, because in order to find slope, you need to have 2 points, okay? But you can never find a slope using only 1 point from the previous example, the equation. So what you want the difference between the P and the next Q point, the difference to be minimal. So before we did 0.01 plus or minus, right? But instead, we want to really, really make sure that it's exact so that h is literally approaching 0. Okay? So we're limiting the slope of a secant as Q approaches P along the curve. So you always have to write limit h approaches 0 every time you're looking for a tangent line, the slope. So these are the 4 steps that you have to remember. So we're going to use this formula. And you cannot substitute h to 0 right away. Why? Because if you have 0 in the denominator, it's going to give you indeterminate case, 0 over 0. So it does not work. Okay. So back in the advanced function class, we learned about difference quotient, which is this one. So we're going to plug it in until that you're able to factor out and cancel h, top and bottom. And once you're able to do that, then you can plug in h a 0. So the next question is number 2. Find the slope of the tangent line to the graph of f at x squared minus 3x at point P. So first, we need to identify what A is going to be. So A, which is a given point, is going to be 1, which is x. And then f at A, if I were to plug in 1 into my function, it says that my output is negative 2. And then we need to figure out what A plus h is. Now, keep in mind, we know what A is going to be. A is 1. So we are going to plug in 1 plus h. H meaning which it's going to approach 0. So let's plug it in. So my input is going to be 1 plus h into my given function over here. So instead of writing x squared, I'm writing 1 plus h squared minus 3. Instead of writing x, we're writing 1 plus h. That's my input into the function. So then I'm going to do FOIL. So 1 plus 2h plus h squared. So I skipped a step. And then minus 3 minus 3h. So you notice that there is a like term. Collect the like terms. And then it will be h squared minus h minus 2. Okay. Now that we have found everything, let's write the equation. So slope is equal to limit h approaches 0. So we want the difference to be very, very minimal, like approaching 0. So let me write the equation first. Now what we're going to do, now every time you write the equation, you have to state the limit until you plug it in. Okay, so we know it's going to be 1 plus h minus f at 1 over h, right? So therefore, limit h approaching 0. So we know the output for this one is this. So h squared minus h minus 2. And then the output for f at 1 is negative 2. Okay, so it's going to be minus negative 2 over h. Now you'll notice that these two cancels out. Negative negative becomes positive 2. So they cancel out. Limit h approaches 0, h squared minus h over h. Now you'll notice that I could cancel h. Now, once you realize that the limit of the h becomes the denominator, it being canceled, then you can start plugging it in. So I'm not going to write limit anymore. Why? Because I'm plugging in 0 into h, 0 minus 1. So you stop writing limit. And then negative 1. So therefore, the slope of a secant line of this function is going to be negative 1. Now the last question. So find the slope of the tangent again to the graph of f at x at x equals 9. So this time, it doesn't give me a full point. It gives me just one point at x equals 9. So, as always, we know A is going to be 9. Now f at a, we're going to plug in 9 into my function, which is 3. So let's see, and then f at a plus h, which we know is going to be f at 9 plus h. Okay, and when I plug it in, it's going to be square root of 9 plus h. So let's write down slope m is equal to limit h approaches 0. It's going to be f at 9 plus h minus f at 9 over h. So let's plug it into the function. So 9 plus h, we found that it's going to be this. So square root of 9 plus h minus f at 9, it will be 3 over h. Now, so we cannot plug in h into as a 0 because it's going to be indeterminate, right? It's going to be, does not exist. So what you can do is rationalize it. So rationalize by finding the conjugate pair. So 9 plus h, 3, but instead of minus, you're doing plus. Whatever you to the top, you got to do to the bottom, plus 3. So limit h approaches 0. So it's going to be 9 plus h minus 3 times 3 is 9. And then h bracket. So instead of doing distributive property, I'm going to keep it this way. And you'll notice that 9 and 9 cancels out. So limit h approaches 0, h over h bracket 9 plus h plus 3. Wow, look. So numerator and denominator. Now I'm able to finally cancel out the h. So that means I can start plugging h into 0. So limit, so let's simplify this again. H approaches 0. It's going to be 1 over 9 plus h plus 3. So now I'm going to plug in 0 into the equation. So I'm not going to write limit now. It's going to be 9 plus 0 plus 3, which is 1 over, when you simplify, 9 plus 3, it's going to be 3 plus 3 is 1 over 6. So therefore, the slope of the tangent to this line, or to the square root of x, is 1 over 6.